All right. Thank you for joining us today at Tulsa Lambda Lunch. We're here thanks to Techlahoma, our volunteers, and our speakers. Techlahoma is a nonprofit volunteer-run organization that puts on 32 groups, 2 conferences, and sponsors free local events. We do all this to support our mission to advance the grassroots tech community of Oklahoma. Learn more at techlahoma.org. Don't forget to sign up for your yearly or your monthly donations. That would greatly help us out. Let's see. It's extremely important to us that our members feel safe and respected at our events. If you have an issue with someone's behavior at a Techlahoma Foundation event, please let us know via the incident report form or one of the other methods provided on our website so we can take action immediately. If you like to get more involved with Techlahoma, go to help-wanted.techlahoma.org to find ways that you can volunteer. This event center is sponsored by 36 Degrees North donates this space for us to meet. They also offer free workshops as well as co-working, desk, and offices for a monthly fee. You can find more info at the front desk. And thank you to Project Make It and Blixa for doing the streaming today. And thank you to Tech Systems for doing the food as always. All right, with that, I'll turn it over to our speaker today, Grant.
Oh no. There we go. Alright, I'll probably, should I wait a second for people to grab the pizza or just go? Alright guys, this talk is going to be kind of an introduction to functional programming. I thought an interesting way to do that would actually be to compare Erlang and Python code, because they're both kind of similar languages in their design, sort of. And then I'm Grant Williams. So a little about me. I'm a Python developer at eLynx Technologies. Really passionate about functional programming and data science, and really kind of interested in seeing how those two kind of intersect. And then I'm interested in concurrent and distributed programming, which kind of goes back to the functional programming and data science. So we'll go ahead and we'll get started. And I realize that most of you guys are pretty familiar with functional programming now, but I want to just do a real brief kind of overview. So functional programming is just another paradigm. It's a way to kind of abstract your code. So the same way you would have imperative programming, where your code is just kind of done line by line, and then object-oriented, where you can abstract away code into objects. Functional programming is another way to structure your code, and it has a few guarantees that are a little bit different from some of the other paradigms. So functional programming, it's kind of a broad category, but generally it's considered to have no side effects. So if you have a function that takes an input A, it will always return the same B no matter what time you give that input to it. So and what that means is that the execution order for your functions doesn't matter. Whenever they receive an input, they're going to give the same output, and that means that you can do concurrent programming very easily. So there's no it really gets rid of a lot of the difficulties you have with state-based concurrent programming, where you can have things lock up on accident. And then the reason I would say learning it is maybe you won't write a purely functional language like Haskell at your job, but the ability to take kind of the way you think with functional programming and apply that to other languages is very powerful. So I use a lot of functional approaches in Python, or JavaScript, for example, is borrowed really heavily from functional programming. So that is why I would suggest learning it. So let's just do a brief introduction to Erlang. I actually didn't do an introduction to Python. I kind of just assumed that people either were familiar with it, or it's basically pseudocode. So if you're not familiar with it, I think it's pretty easy to read. So Erlang is immutable and functional, and what that means is that when you set a data structure or a variable to a value that can no longer be changed. It runs on a virtual machine, sort of like Java or Scala. That virtual machine is called the Beam. It was originally made for the telecom industry, so I actually don't think Erlang was intended to be a purely functional language. I think they just developed it for telecom, and then as a side effect, it ended up with all these functional features just because the way they needed a distributed language for the telecom industry just lended towards a functional language. Another thing that came from that telecom industry is that it's extremely fault tolerant. So over a 20-year period of time, one of the Erlang systems that's been up has been running for 99 point, I believe it was 99% uptime, which means it had a 0.6 second downtime over 20 years. So, and part of that is because you can actually hot update code in production without taking it down because of the kind of way that each individual function is totally isolated, which has its own problems because you probably don't want to be hot updating your production code all the time without making sure that you know what you're doing. But it is completely possible. And then concurrency is very trivial in Erlang. The entire language is built around it. And it's actually built on this thing called the actor model, which the last talk I gave for Tulsa Lambda launch was on the actor model. So if you want more information on that, you can go ahead and check it out. Basically, it's just when you're doing concurrency in Erlang, you have a mailbox. You send and receive letters. So you don't have to worry about things becoming locked up because it's all done through message passing. So this is the part of the Erlang syntax that people really don't like. It's actually based on Prolog, which is a very, very different syntax than you're used to seeing with C-based languages or even Fortran-based languages. So this is the part that trips up most people. There are 3 types of punctuation in Erlang. So in the same way you would have a semicolon in most lines in C or C++ outside of like if statements, the Erlang code has 3 different separators. So the first one is the comma. So if you have like a main function, each line of code in that main function is going to end in a comma saying that we're not done with this function. We have another line of code that needs to be executed. The last line of code in a function is the period, and that is instead of having return a, you would just write a period, and that's saying that whatever happens on this line is what's returned. And then the last one is semicolons. So use these inside of if statements, switches, which in Erlang are actually called case instead of switch, or when you're doing receive when you're using the concurrent programming. So basically in the if statement, if you have branches, you're going to separate each of these branches with a semicolon, and that'll actually go over into the pattern matching as well. All right, so this is where we talk about Erlang's pattern matching. First off, the equal symbol in Erlang does not actually mean a sign or equals. It means pattern match. And so, and that's a little bit different in Erlang because it's completely immutable. So if you look at this example, we can assign a variable num. And a side note, the variables in Erlang have to start with capital letters. It's a little old school in that. It was made in the 80s, so I guess that makes sense. So you have number equals 42. And so that is how you assign a variable. But if you try and take that same num and set it to 43, what it's actually doing is it's saying, okay, I'm trying to pattern match this num variable to 43. And because num is 42, it's saying num 42 equals 43, which is not allowed, so it throws an exception. You can't match the 43 to number. All right, so let's take just a little bit deeper look into the pattern matching. I wasn't trying to get super into Erlang. I was hoping this would be a more generic talk, but I realized that if I just throw a bunch of Erlang code on there, no one's going to know what's going on. So in Erlang, one of the biggest things you use is a tuple, which is honestly almost identical to Python. So it uses curly brackets, and the same way Python uses parentheses. All right, so you can use the same pattern matching. So here we have this point variable, and we give it a tuple that has, this is a point, so we're going to send it a x and y coordinate, and we're going to give it a direction. And then later in the code, we might have x, y, and direction variables that we can unpack from that point the same way you would with a Python tuple. So last note, this lowercase west right here is a little bit weird. It's called an atom. It's kind of like a string that's completely immutable. It has no value. The value of the atom is actually just its name. And there's a few that you use often: true, false, okay, error. Those are actually not keywords. They're just atoms built in the language. Sorry about that. All right, and then I think this is the last bit of syntax. For pattern matching, we can go ahead and extend this to function calls as well. So I'm sure most of you who have ever written any kind of recursive function, the first thing you learn is Fibonacci. And even though it's actually kind of a bad use of recursion, it's very easy to understand. So here we have a Fibonacci function that is runnable in Erlang. And you can see we have our statement down here that we're going to take a variable in, and then we're going to add the two previous values of that n. And then what happens is if that Fibonacci receives 1 as the in slot, it's actually going to pattern match on that and return a 1. And if it receives a 0, it's going to return a 0. So this lets you do pattern matching at the variable level, and it's a little bit different from the way other languages do functions. So you can see that they're all named fib, and that's actually allowed. So instead of having 3 different functions, this is all the same function. And the final thing to note is that because this is basically just using an if statement at the function level, we have to end these in semicolons and then this final one in a period because it's the return. So it's basically just allowing you to do an if statement in a cleaner way. I lied. We have a little bit more syntax. Sorry. So the other thing we use often is case, and this case statement is similar to a switch. So we might have this function up here, prelude, that takes a string, so it can take result1, result2, or other. And this case statement says, all right, if we have a string that matches result, we're going to do this action. If we have a statement that is result2, we're going to do this action. And if it's any other value, this underscore matches to anything that's not something we give. So this is the default case, so it will print, in this case, whatever you return to it. So it'll print hello world. All right, so let's actually get into comparing Python and Erlang. The easiest thing I could think of and kind of in general would be to make a list of numbers 1 through 10. And I wanted to show kind of the way you would do that in Python and Erlang. So I realized to do that in Python, you would normally just use range, but that's not showing this at all. So instead I had to do it using a for loop, which I realized also uses range. So instead we're using a while loop in Python, so please don't be upset. But this is our wonderful custom range function. So we define an empty list, we set an iterator to 1, and then we say while that iterator is less than the value we want, we're going to go ahead and append that value to the list and then increment it by 1. So when we run this, we'll get 1 through 10. And in Erlang, we can do something similar. So there's no loops in Erlang. Everything has to be done through recursion because you can't increment in. You can't do n plus 1 or it'll break the program. So the only way to do this is to recurse while adding to the function call and increment. So up here we have this function range, and this is the final bit of syntax about Erlang that we need to know. So you see that we have a range that takes 1 argument and a range that takes 2. So these are actually totally separate functions. They just happen to share the same name. So you'll see that this one ends in a period, so does this one. So we take this range, and then we're just calling our other range function, which says that the lower bound is 1. So it's just a nice little syntactical sugar. So when we receive this function call range 1in, it goes to this function right here, and it says, that while the lower bound is less than the upper bound, we're going to go ahead and make a list, and we're going to add the lower bound to that list, and then we're going to add whatever the value from the next function call when we increment it by 1. And then down here we have a guard that says, all right, if the lower bound is above the upper bound, we're going to return an empty list, and we're not going to recurse anymore. So when you run this code, each time it will just add the L to a list, and then when that L is bigger than the U, which in this case is 10, it will return the list. Now, realistically, if you were going to do this in these two languages and you wanted to print 1 through 10, you would use the sequence function or the range function. So they both do have easy ways to do things as well. All right. So one interesting thing about Erlang is it has list comprehension in the same way that Python does. So in this one, we want to make a list that has even numbers in that same range of 1 to 10. So in Python, what you do is use square brackets, and the first section of this list comprehension, this x, is going to be return the value. And then we have for x in range, and this is saying this is where x is going to loop through. And then finally, if that x is even. And this returns 2, 4, 6, 8, 10. Now in Erlang, it looks almost identical. So it's the same setup. We have this square bracket syntax, and then we have x is our return value. And then this double pipe operator is what separates the return. So everything to the left of the double pipes is returned. And then we have this same pull one x from this sequence of numbers 1 through 10. And then finally we have if x remainder 2 equals 0. So you can see that list comprehension is almost identical between the two. They have the same return value, loop value, and then you have a area for clauses as well at the end of the loop. All right, so this is where we break my only rule with presentations, and we're going to do just a little bit of live coding. So we're going to look at the Project Euler problem number 1, which is we have a list of numbers. We want to see what all of the multiples of 3 or 5 below 1,000, and then add all of those together. Now, it is important to note that it says below 1,000, not including 1,000. When I did this the first time, I got the wrong answer, and I couldn't figure out why. And that is because they did not include 1,000. All right, so we'll go ahead and start with Python. So we have this function up here, and all we need to do is make a return statement that returns the numbers that are divisible by 3 or 5. So what we're going to do is we're going to go ahead and do a list comprehension. So we're going to say x for x in range of 1,000, which in Python does not include 1,000. If x is not, or if x is divisible by 3 and x is divisible by 5. Then we're going to go ahead and sum those values. And then we should have, theoretically, some code that will allow us to print these values. So if we save our code and run it, we do not. Let me see. Oh, sorry, I meant to do or instead of and. Read the problem wrong. So we're going to do or this time. All right, there we go. And then you can see that our answer needs to be 23,170, and we get 23,168, which is not great. Let's see. Oh. I guess I copied the answer wrong. The one on Erlang is the correct one, so it's actually supposed to be 168. That was my bad. All right, yeah, because the answer over here is 168. All right, so that worked. So basically, we just use the list comprehension with an if statement to check if it's divisible, and then we can go ahead and find out if it is. So going over to Erlang, back to presentation mode. For this one, instead of doing a list comprehension the same way we would do it in Python, which is a totally valid way to do it, we're going to do it just a little bit differently. So in Erlang, you can do a filter statement like this. And what this filter statement does is it allows you to define a function, x, that takes x, and it says if that x, remainder 3, equals 0, or that x, remainder 5, equals 0. And then we need to give it a range of numbers. So in this case, we'll do it 1, 2. So Erlang is a little different from Python in that it actually includes the final value. So we want to go to 999 instead. And then that will filter our list for us. And then finally, we can just sum this value here. And then if we go down, now you can running Erlang code is a little bit different because it's actually a compiled language. So what we have to do is we have to open our terminal here, go into the does presentation mode include the terminal? It does not. All right, we'll just go ahead and I'll just compile it real quick. It's not interesting. And then, all right, so it does give the same output as the required answer. So, looking at this code one more time, basically what we're doing is we're passing in a filter statement on top of a list, and then we're summing that filter. So, and this is actually also possible in Python. Python also has the filter statement, and Erlang also has the list comprehension, so you could do that as well, but it's actually a little faster to do filter in Erlang because of the way the VM is optimized. And then for our last problem, we're going to do the Fibonacci sequence. So what we're doing is we're going to find the Fibonacci sequence where the Fibonacci numbers are below 4 million, and then we're going to add all of the even numbers together. And then this is probably where we'll see the biggest difference in the two languages. So for a problem like this in Python, I would do it iteratively. So what I would do is I would say our summation, which we'll call answer, we're going to set that to 0. And then we're going to set two variables to 0 and 1, which are the starting, I guess it doesn't matter, the starting values of the Fibonacci sequence. So so we're going to say while x is less than, is this equal to, does not exceed 4 million. So less than or equal to 4 million, which you can use scientific notation for that. We're going to say if x is even, we're going to go ahead and add x to our answer. And then we're going to say x equals y and y equals x plus y. And then we can return our answer. And then in theory, this should provide the correct answer. All right, and it looks like it does. So you can see that this is, we're just using iterators, and it allows for a lot more, I would say a lot more errors. It's a lot easier to mess something up because you have this kind of state-based looping and this bad unpacking code down here, which you probably shouldn't do in production, but it's okay. So, and then let's look at how we would do this in Erlang. So for this one, we're going to need to define a Fibonacci function, and that function is going to take just the values of our list, and it's going to unpack them. This part's not as important, so we don't have to worry too much about the nitty-gritty details. Okay. And then basically what this is doing is doing the exact same thing that the function that Python does. So this is an iterative solution instead of recursive. It's building a list, and then in that list, it's going to add the last two values and then stick that back into the list each time. Which I know it's kind of a gross notation, but that's all it's doing. So it's not doing anything crazy. And then we're going to say when that value becomes over 4 million, we're just going to go ahead and return the list. And then for our function down here, what we're going to do is we're going to do the same filter. So first we're going to do a filter. We're going to say we're going to take an x value for this filter. We're going to say if this x is even, which and Erlang is the remainder. And we're going to say, instead of giving it a list of like a range for it to go through, we're actually just going to call the Fibonacci function that we defined, which returns our Fibonacci numbers in that range. And then this is just filtering those for a even value. And then we can go ahead and sum that as well. Then running this. Ooh. Oops. And then we get the same answer there. So another way you could do this one actually is if you want to do it in a more Pythonic way, and probably easier if you're used to Python, is you can take this x value and just do a list comprehension. So what we're doing here is we're doing the exact same thing. We're going to call that Fibonacci function to get our Fibonacci values, and we're going to use a list comprehension and just say if that x is even, then we're going to go ahead and return it like this. And then that will do the exact same thing. And then that is all I have. Go back to the slide. So does anyone have any questions about Erlang or Python, or why you should use them or what they're used for? Yeah, so Erlang has a built-in kind of like a web server, and basically it allows you to spawn processes very easily. So I was originally planning on doing a prime number problem. I probably should have left that in. And for example, for prime numbers, if you wanted to set up a function that instead of doing like a sieve, you could do just a function that divides by numbers and sees if a number is prime, and then you could spawn a process for every single number in a range, and it will tell you which one of those are prime. So on my laptop, which is a early 2013 MacBook Pro, I can handle 1 million processes without any problems. I haven't really tried going higher because I haven't had a reason to, but it's they're super lightweight, so they're quite a bit different from threads and other languages, but it gives you a pretty good speed increase. And if you want to do it in parallel across all the cores, you just pass it a flag that says I want to do it parallel, and it'll auto scale. And it has a load balancer that will make sure that all of the cores are being evenly used. And if any thread is really long, it'll actually pause working on it so that the load is actually distributed evenly and not just the small numbers end up on a couple cores and then one core is crunching all the big numbers. So. Oh yeah, the question was how easy is it to use Erlang for distributed programming or concurrent programming? Sure. So Erlang is actually also very bad at math, but what Erlang is really good at is handling requests. So it's a fantastic queue or message queue. It's good for brokering web servers. You can actually do a lot of really cool front-end programming with it. So there's a library out there called Nitrous that allows you to pre-render HTML on the server and then serve that to mobile or desktop devices for really cheap, and it's super scalable. And what makes it interesting is it's really easy to work on binary with Erlang. Binary is kind of like a first-class data type, so you can do all these efficient calculations on binary, or use flags and binary and stuff like that. So it allows you to do basically web servers, and message passing is very easy in Erlang. That's what I would use it for. If you have really like scientific code, I would not use Erlang. Yeah, telecom. If you are in telecom, Erlang's great. WhatsApp uses Erlang because they have so many messages. I think they have 5 servers that were serving like 1 billion people on mostly Erlang for the core distribution code, and then, you know, all of their code that does things like make the app not look terrible, you know. So.
What about the relationship between Elixir?
Yeah, so they're both built on the same Beam VM, and Elixir, you don't really have a reason to learn Erlang, I guess. You could learn Elixir first. Elixir has a syntax based on Ruby's, and then it operates completely fully with Erlang. So you can use modules in Elixir and Erlang and just use them together, and they work perfectly. Kind of like Scala and Java. But I actually think it might be easier to mix and match Erlang and Elixir. But that's subjective, so it's not hard to do either. That's what I'm saying. Yeah, so Erlang has hooks for C, so it's very easy to do. Yeah, so if I was doing something, I would do it kind of like microservices, where I would make individual services in C and then use Erlang to kind of handle these individual services. That way you kind of still keep that kind of functional style, but without having to use Erlang for scientific code. Yeah. Yeah. So I think there's 3 ways to interop with C. There's the FFI, there's ports, and then there's, I don't remember the last one. I don't know how often it's used, but those are the 2 ones I see used like in industry. Mm-hmm. Yeah. All right. Well, I guess that looks like it's it. So if you want to connect with me, you can. I don't know why I put my Hackerrank on here, but I figured out that you could share that for some reason, so we can become Hackerrank friends. I don't know what that lets you do. Yeah, they're not that hard to figure out. I think it's G Willie. This is unfortunate. I don't know why I didn't. Yeah, I don't know. That was before I was, doing consistent things. I was all over the place, so. Yeah, so I don't know if we can like code on Hackerrank. I've never actually tried it with friends, but apparently you can add them. I got a notification the other day about that, so. Oh, if we could code fight, then throw the gauntlet. I'm down. That'll be fun.
All right. Well, thanks everyone for coming. We will not be meeting in December because it's way too close for Christmas and nobody wants that. So our next meeting will be in January. Techlahoma's doing Techmas with I forget, but check Meetup and you can see that WebDevs is also doing the Techmas thing, I think.
Cool.
I need speakers for next year. Otherwise, you're going to hear me talking about Scala again consistently. So if you have anything you want to hear about, anything you want to talk about, please reach out to me on Slack and we'll get you scheduled for sometime next year. So thanks again to Grant for doing the talk.